I'm going to build a glucose molecule from these little edible tidbits here. You don't have to use what I have here. I've got cheese, grapes, raisins, peas, and some push pins, which I don't intend to eat afterwards. But you can make your model edible or not edible. You can use little balls of clay or Play-Doh or anything you have around. If you are lucky enough to have a molecule building kit, you can use your plastic molecules and build along with me. So use whatever is easiest for you in your situation. Like I said, it can be edible or it can be not edible. It doesn't matter, either one. So I've decided I'm going to use this white cheese for my carbon atoms. In molecule kits, carbon is almost always black. However, I'm going to use the cheese because it's the most firm and solid for taking the toothpicks. I think I'll use my red grapes for the oxygen. Oxygen is usually red in a molecule kit. And then I'll use these smaller things for hydrogens, either green peas, raisins, or here, if you don't mind using some non-edibles in your edible model, you can even just use a push pin, stick it in the top part, just imagine that's the hydrogen, and then you don't have to have a long pick sticking out from it because hydrogens are very small and they stick close, so push pins will be fine too. So we're going to build our model from scratch, just knowing how many of each type of atom are in the molecule and knowing a little bit about each type of atom. So the formula is C6H12O6. So we've got 6 carbons, 12 hydrogens, and 6 oxygens. So let's count those out. Alright, so I've got what I need. Now I just have to arrange them. Now we're used to seeing glucose as looking like a hexagon, sort of a hexagon with a little flag like this. But glucose can look like straight, so it does take different shapes. I think it's best to start out with the hexagon that we're used to seeing. So you're going to take your carbons, whatever you're using as carbon, and arrange them. You could start out by just arranging them in a hexagon as long as you know that you're going to have to fix it. You'd think that it would be like this. That would make sense, right? But in fact, you need to take this one right here and put it up like that. So we've got a gap in our hexagon. So we're going to fill that with an oxygen. So there's our basic structure right there. So I'm going to go ahead and put toothpicks into these and get these to stick. And you know what I'm going to do is I'm going to make my picks a little bit shorter. I'm going to take a little bit off and make them a little bit shorter. And that little end that I saved, I could use this for these things later on possibly, especially if I take off the smaller pointier end. Now we need to place the rest of the oxygens. We're going to put one up here for that carbon. And then we're going to put 1, 2, 3, 4 like this. I'm going to use half a toothpick to put the oxygens on. Now we need to carefully count bonds. We know that carbon wants 4 bonds, oxygen wants 2, and hydrogen only has 1. So for example, look at this oxygen. Oxygen wants 2 bonds, and look, 1, 2, it's got 2 picks sticking out. So this guy's okay right now. We don't have to do anything to that atom, it's happy. But these carbons all have just 3. You see how there's 3 picks coming out of each one? So they're not real pleased. So we're going to have to give them each a hydrogen. So now that guy's happy. 1, 2, 3, 4. So give each of the carbons a little hydrogen. Hydrogen I always think of as being like a little cap. Whenever anything, you got a bond hanging off or somebody's unhappy, you stick a hydrogen on it and everyone's happy. And of course, there isn't really a stick between the atoms. The stick just represents the electrical attraction. Keeps them together. Give this guy 1, 2, like that. Okay, now who's still unhappy? Well, we've got these oxygens hanging off here. This one, this one, this one, this one, and this one. They all have just one pick out from them. They're attached to the carbons, but they want 2 and they just have 1. So let's give them each a hydrogen. Now I've used 11 of my 12 hydrogens. Can you see who's still unhappy? See, this guy's fine. This guy, all the oxygens, they have 2 bonds. They're all fine. This carbon's fine, this carbon's fine, that carbon's fine. What about this carbon up here? He's attached to the oxygen. Here he's got a hydrogen, but there's no 4th bond sticking out. So this carbon up there would like to have that last hydrogen. So we'll stick it right there. Okay, now I think everyone's happy. So there we have our glucose molecule. So what if we wanted to make this into the straight form of glucose? Well, if we break it right here, like this, we could make these carbons go into a line, couldn't we? But I've got some unhappy atoms now. There's a broken bond here, and I broke the bond here. So how would I patch this up? So how about if I take this off here, pop this red oxygen off, and this bond here, I'm going to swing it down like this, and I'm going to tell this carbon to make a double bond with this oxygen. So there we have 1, 2, 3, 4 bonds. It's bonded with this carbon, this hydrogen, and it's double bonded with this oxygen. So therefore, I don't need this, do I? Oxygen is happy with 2 bonds. There's the 2 sticks going out, so this hydrogen was extra. So I've got that left over. So let's see, who's unhappy now? This guy's happy. This guy is still got 1, 2, 3, 4. We're still good. This carbon still has 1, 2, 3, 4 bonds. This guy's still good. Alright, so here's the unhappy one up here. So we're going to have to bring this up like that, and then put our extra hydrogen like that. Right, so this guy's happy now. 1, 2, 3, 4. That guy's alright, so everybody's happy. So there is a straight form of glucose. There's another molecule you can make with the exact same atoms, 6 carbons, 12 hydrogens, and 6 oxygens. You could also make the simple sugar fructose. It has the exact same formula, but they're just arranged differently. So in fructose, you start out with a pentagon, a 5-sided figure. So we'll only need a couple of these, and oddly enough, see, it's like that. 1, 2, 3, 4. We are going to use an oxygen as our 5th. Remember, we had an oxygen stuck into the this place, that area in glucose. So we kind of have the same configuration where you have almost all but one of the central shape being carbon, one oxygen. But now instead of having just that flag, we've got two left over. So we're going to have to put one up here hanging off and one down here hanging off. And now we play the same make everybody happy game. This one's already done. He's pretty happy. But now we have to add these, gotta get all these oxygens on. A little bit easier if you've left the hydrogens on too. So put that guy up there. Give him an oxygen. Give this guy an oxygen. Give this guy an oxygen. And this guy gets an oxygen. And this guy also gets an oxygen. So you've got a carbon here that's hanging on to two oxygens. Alright, we already have one hydrogen in place, but now it's time to put the rest in place. So we'll just kind of go down through the molecule. So this carbon's unhappy because it only has two bonds, one here and one here. So we're going to give him two hydrogens. So that's kind of like our little flag. And then this guy, 1, 2, 3, is almost happy. He needs one more, right? This guy needs one. And this one also, this one needs one. This one needs one. And this guy down here needs two to be happy. So it's got 4 bonds. And then, let's see, what about this one? 1, 2, 3, 4. He's already hanging on to 4 things. So how many hydrogens do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we need 4 more hydrogens. And how about here? Make that one happy. And here's one that's unhappy. That one. And here's one that's unhappy. And there's one that's unhappy. There. And there you have fructose.